Yo, what's up, YouTube? It's the Greg Domine. So, as the title is read, I have a chemistry assignment to present at the class. Uh, so I'm gonna check the questions out. How it's gonna be. It's not gonna be hard. Um, yeah, yeah. So let's take the question and just solve it again. I saw some mistakes on my the one that I submitted last time. So let's just answer the questions again with accurate variables and unit conversions. Oh, you cannot see. My bad, bro. My bad. My bad. I'm sorry, man. I'm sorry. I'm sorry, man. Okay. Doing this. There we go. There's the little me on the top, and yeah, uh, yeah. That's it. That's it. Figaro, Figaro, Figaro. Bing, bing, bing. Onde partirò? Oh, fucking idiot. Why you gotta do that? We gotta be in a, we gotta be. So, a certain amount, okay, this is the question I gotta present to the class full of people. Hey, there's gonna be 20 people in front of me, and I'm gonna start saying like, so the from the question number 10, we understand that it's free business first of all. So from the statement of the question, a certain amount of an ideal gas is transferred to another state by variation of one, two, and three or three variables. Variables. Calculate the missing properties in the following table. From this, we can conclude that from this we can conclude that we can conclude some of the things that we use the ideal gas law equation, that is PV equals nRT, in which the it's about initial and final state. So it's gonna be more like P1 V1 by T1 equals P2 V2 by T2. T2, yeah. And oh, bro, shut the yeah. So what we do here is so I'm using so many words because my mind is not, it does not have the words I need to produce. So what I was saying was the equation can be concluded as P1 V1 by T1 equals P2 V2 by T2. You're going to be asked, the value n is canceled because it's a closed body system. I believe it's a closed body system with just initial and final state. That means the number of moles does not change. Just the state of matter changes, which does not have to do anything with the number of moles. I believe. Let's see what the Satinka. What do you think, ChatGPT? To calculate the missing property for scenario where pressure volume while others remain constant. Why does the number of moles constant? I gotta write this, bro. Gotta write this. The number of moles of an ideal gas remains constant in this calculation while analyzing a closed system. Yeah, I was right. It's a fucking closed system. Closed system where no gas is added or removed during the process. In other words, the mass of a gas does not change between initial and final states. The system is sealed, so the amount of gas present before and after transformation is the same. Yeah, so it's a close. Just the question number 10, ChemCalc. Chemical calculation assignment number two. Number two. Question number 10. What do we do here? It's the initial state and the final state. You gotta take those back. No, okay. So how do I explain? So from the question, we can see that about. So from the question, it's confirmed that this question use. So so from the question, we can say that. So it's just changes in the state. No, in the state of matter, states of gases. So it's just changes in the state of. Oh no. Yeah, okay. So from the question, it said that the ideal gas just undergoes uh, changes in states of matter, states of its. These changes represent different state of the same fixed amount of gas. Okay, so from the question, we can see that the. I got 40 minutes. Come on. So from the question, we can see that it's an ideal gas. So we're going to be using the formula PV equals nRT, in which in which it's in which it's in which it's known that the gas is under a closed body system with changes in variables of pressure, temperature, and volume. These are the three states. These are the three variables that change. think when we study gas transformation, it's important to remember that the number of moles remains constant as long as the system is closed. So from the question, we can understand that the system it's a closed system in which the states of the gas are just changing. State variables such as pressure, volume, and temperature. From the question, we can understand that it's a closed body system. That is no amount of, which means no gas is added, no gas is added or removed during the process. From the question, we can understand that this is a closed body system, which means no gases are added or reduced, no gases are added or removed during the process of changes from initial to final state. The changes are actually seen in the three state variables. The changes can be observed in the three state variables, that is pressure, volume, and temperature. From this, we can formulate and we can come up with an equation of P1 V1 by T1 equals P2 V2 by T2. And we're going to calculate using this equation. So let's start with the first question. So the first question is the pressure is 35 bar. So from the first question, we find out that we need to find P2. We can see that P2 is the value that is missing. So if we try to formulate P2 from this, and we should also know that temperature is constant, therefore we don't have to look into the temperature. The formula would be P2 equals V1 by V2 into P1, which implies the value P1 is 35 bar, and P2, no, I am stupid, I'm ignorant. So it's V2. That's so from the question we can see that V2 is the missing variable, and to calculate that, converting from this equation, it's going to be V2 equals P1 by P2 into V1, which implies P1 equals 35 bars, P2 equals 350 bar, and V1 equals 80 liters. SI unit of volume. 80 liters, which converted to SI units, it's going to be 80 into 10 raised to minus 3 cubic meters. So if we plug all that into the equation, it's going to be 35 by 350 into 80 into 10 raised to minus 3, which cancels 10 8 into 10 raised to minus 3 meter cubes. That cubic meters would be the volume, resulting volume due to the changes in pressure. Due to the increase in pressure. Now let's go to part B. From part B, we can see that P2 is the one missing. So P2 can be formulated as P2 and temperature is constant. So temperature is still canceled. So P2 will be V1 by V2 into P1, in which if we state the values, P1 is 1 Pascal, V1 is 30 cubic meters, V2 is 300 milliliters. So I'm converting that to meter cube milliliters to cubic meters. So milliliters to so if I'm converting meter cube to cubic meters, it's 300 into 10 raised to minus 6 cubic meters. So applying the values, it's going to be 1 Pascal into 30 cubic meters by 300 into 300 multiplied by 10 raised to minus 6 cubic meters, which is canceled to 30 cancel. It's 10, which gives 1 into 10 raised to 5 Pascal. 10 raised to 5 Pascal, which is 1 bar. I believe it's 1 bar. We can say it's 1 bar. So the resulting so that's the resulting pressure for the decreased volume. Now we go to C. From C, we can understand that pressure is constant. So from the equation, it's going to be we can see from the third part, we can see the pressure is constant and T2 is the one that's missing. So T2 equals 1 Pascal into 10 raised to minus 6 cubic meters by 300 into 10 raised to minus 6 cubic meters, which is canceled to 30 cancel. It's 10, which gives 1 into 10 raised to 5 Pascal. So I'm converting that to So T2 equals V2 by V1 into T1. V2 by V1 product multiplied by T1. And the values, let's see the values. So V1 is 24 cubic centimeters. V2 is 48 milliliters. And T1 is 295 degrees Celsius. So cubic meters to milliliters. Cubic centimeters to milliliters, how much? Okay, so it's equal. So it's 24 milliliters itself. If you convert the values, it's going to be 48 by 24 into 295 degrees Celsius, which gives 2 into 295, which is 400 plus 95 into 2, 180, 180, 180, 190, 490, 490, 590. 590 degrees Celsius. That is resulting temp resulting increased temperature due to the decreased volume. Oh no, resulting increased temperature due to increased volume. Now let's go to D. On part D, the volume is constant, so the volumes are constant, so it's P1 by T1 equals P2 by T2, in which we have to find P2. So P2 equals T2 by T1 into P1. Yeah. So if we list the values, 30 minutes, bro. I got 30 minutes. Okay, bro. Okay, P1 equals minus 3 Pascal. No, bar. It's a bar. Temperature T1 equals minus 100. That would be once. I forgot. 173.1. Whoa. Why are you coming with that? So temperature is minus 100 degrees Celsius, which is 173.15 Kelvin, and T1 equals 100 Kelvin. So plug away the values, it's going to be 173.15 by 100 into 3.41 into 10 raised to minus 3. Which will be resulting a value of 59. It's gonna be in bars, so no, 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 no. 543, which implies 5.43 into 10 raised to minus 3 bar. Resulting pressure, so that is the resulting increase in pressure due to increase in temperature. Now it's part for E. On part E, the P2 is the value that is missing, so it's going to be P2 equals, and we have all the other, so P2 equals T2 by T1 into V1 by T2 by T1 into V1 by V2 into P1. So if you list all the values, P1 equals 23 megapascal. V1 equals 78 liters. V2 equals 3.2 cubic meters, which gives G equals 3.2 into 10 raised to 3 liters. And T1 equals 20 degrees Celsius, which is 193.1. As the temperature, one of the temperature is in negative, so the degree Celsius are represented in negative, so we gotta change both to Kelvin. T2 equals minus 20 degrees Celsius, which gives 153.15 Kelvin. So it's not that hard. So plugging in all the values, 78 by also 23 into 10 raised to 6 Pascal. which will be giving 0.79. 437. Which can give you approximately 44 44 bar. That is the resulting decreased pressure due to the changes in values that I did. Resulting reduced pressure due to reduce in temperature and increase in lead volume. I'm so hungry, bro. And last part. So in the last part, we are missing V1. V1 equals P2 by P1. P2 by P1 into T1 by T2 V2. So listing all the values, P1 equals 666 millibars. Which implies 666 into 10 square raised to 10 score 10 into 10 raised to 2 Pascal. P2 equals here it's better to convert. See here I converted the millibars to bar, which is 6.66 bar, and P2 equals 8.6 into 10 raised to 3 kilo Pascal, which can be converted to bars as 86 bars. 86 bar, and T1 equals 56 Kelvin. T2 equals 56 degrees, so 50. It is converted to Kelvin as 229.15 Kelvin. And V2 equals 200 cubic centimeters. I think it's 10 raised to 3, right? Oh shit, it's 10 raised to minus 6, okay. P2 equals 86 by 0.666 into 56 by 229.15 into 200. So we are gonna get 6,192 cubic centimeters, which can be converted to 6 point 6.19 into 10 raised to minus 3 cubic meters. Volume volume is increased as pressure decreased, as pressure has volume has increased with pressure being decreased. So volume did change from, so volume got, as pressure increased, so volume decreased as pressure increased and temperature increased. So that's all it took. That's all it is. Okay, so from the start, from the beginning. Use That's the worst. It's Pascal. 543 Pascal. .4 bar. In which the answer can be written as 4.4 bar or 4.4 into 10 raised to 5 Pascal. The last one, volume is meter cube. It's Pascal. Pascal. 1 bar, it's meter cube. Okay. As you can see from the question number 10, yeah, that's it. I have 15 minutes. I gotta do everything fast because I gotta get to class real fast, bro. I don't want to waste time, bro. Just after one question, I'm gonna be doing this. It's not a big deal, but you know, I'm in the stream here, by Bobo. See, man.